feeling like you're swimming in an alphabet soup of tech terms? AI, ML, Gen AI. It seems like every single day there's a new one to learn. Well, you are definitely not alone. So today we're going to clear all that up. We're going to build a really simple picture of how all these powerful technologies actually fit together. So how are all these things connected? Are they the same? Are they totally different? We're going to walk through it layer by layer, kind of like peeling an onion, starting with the oldest, biggest ideas, and working our way down to the latest breakthroughs that are changing, well, pretty much everything. Okay, first up, let's look at the big picture. To get a handle on any of this, we have to start with the absolute foundation, the giant umbrella that covers it all: artificial intelligence.
At its heart, AI is really just this huge, ambitious goal to make computers think like us, or maybe even better. It's the entire field dedicated to giving machines the power to learn, to reason, and to connect the dots, just like a person would. Everything else we're going to talk about lives inside this idea.
Now, what's fascinating is that AI isn't some new kid on the block. Not at all. It's been around for decades. Back in the 80s, it was mostly hanging out in research labs built on old-school programming languages. Then, in the 90s, we started seeing these things called expert systems. But it was really in the 2010s that machine learning started to go mainstream, and that set the stage for the revolution we're seeing today.
So, let's peel back that first layer of our AI onion. This is a massive subfield that honestly changed the game: machine learning. This is the point where computers stopped just following a list of instructions and actually started to learn on their own.
And the key is right there in the name. The machine learns. See, instead of a programmer having to write code for every single possible outcome, we just feed the machine a mountain of data, and it starts to figure out the patterns all by itself, so we can make predictions.
Think about it like this. If I show you a square, then a circle, then a square, then another circle, what's next? You'd probably say a square, right? Your brain just spotted the pattern. That's exactly what machine learning does, just with way more complicated data. But okay, what if the pattern suddenly breaks? Your brain immediately flags that triangle as weird. It's an outlier. It doesn't fit. And this right here shows you one of the most powerful things machine learning can do: spot anomalies. And that simple ability to spot the odd one out has some incredibly important uses in the real world. Take cybersecurity. ML algorithms are always watching for a user who suddenly acts out of character. You know, that triangle in the data, which could mean there's a security breach. All right, let's peel back another layer. So inside the world of machine learning, there's an even more specialized way of doing things that tries to copy the most complex computer we know of, the human brain. And this is called deep learning. The big idea here is neural networks. These are these really complex, multi-layered systems that are inspired by how the neurons in our own brains are all connected. And the deep part? That just means there are a lot of layers, which lets the machine learn in a much more sophisticated, nuanced way. And this quote just nails it. Just like our own brains, these deep learning models can be a bit of a black box. You feed data in, you get an answer out, but because of how incredibly complex all those layers are, we can't always pinpoint the exact reason why it made a certain choice. It's unbelievably powerful, but yeah, also a little mysterious. And that brings us right to the center of our onion. This is it, the technology that has absolutely exploded into the mainstream and is driving almost everything you hear about AI today: generative AI. This is the huge leap. Generative AI doesn't just analyze or predict, it creates. It makes brand new original content that didn't exist before. And the engine driving all this magic is something we call a foundation model, with large language models, or LLMs, being the most famous kind you've probably heard of. Now, you hear this argument a lot, that Gen AI is just copying and pasting stuff from the internet. But let me ask you this. We've had the same handful of musical notes for centuries. Does that mean no new music can be created? Of course not. Gen AI is a lot like that. It uses the existing building blocks of information to compose something totally new. And the stuff it can create is just astounding. We're talking chatbots that can write a whole term paper, deepfakes that can perfectly mimic a voice, and algorithms that can compose music, generate video, or even just summarize a massive report into a few key points. It's generating, not just repeating.
Okay, so we understand the layers now, but that leaves one big question. Why? Why did generative AI create this massive wave that we're all riding? Let's zoom back out for a second And look at the incredible impact it's had.
This chart really tells the whole story. For decades, AI adoption was slow and steady. Then machine learning comes along, and you see a nice little bump. But when generative AI and its foundational models showed up, adoption didn't just grow, it went straight to the moon. We're talking an exponential explosion.
And this is why. This is the whole reason for that explosion. Foundation models made this incredible power accessible to everybody. Before, you pretty much had to be a data scientist in a lab coat. Now, suddenly, anyone with a web browser can use AI to create things, to summarize information, to solve problems. It's for everyone.
So, there you have it, a clear map of this new world. AI is the universe. Machine learning is a galaxy within it, deep learning is a solar system, and generative AI is like the exploding star right at the center. We figured out the what. But now we're left with a final, much bigger question. As this tech gets better and better at generating content that we can't tell apart from our own, what does the future of generating reality itself actually hold?